Hello friends, welcome to you all here in this particular session. Here we will discuss mixture and alligation topic. This is one of the very important topic in respect of your prelims as well as mains examination. If you can understand this topic in a best possible manner, the approach to different kind of questions would change significantly and you can solve more number of questions in less time. And understanding this concept is very much important so that you can solve even the DI sets in the mains level questions in an efficient manner. So moving to the concept based understanding here, and then we will solve some questions. The questions we will solve here is level 1 kind question you can understand here, and further in the upcoming session we will just improve the level of the questions. So moving to the concept here. Now, mixture and alligation is the topic for our purpose here in this session. Now, first of all, just understand this image here. If one weight is here and one weight if we put here, supposedly here is 50 kg and here is 60 kg, right? Supposedly this is ball, the iron ball, one is 50 kg, right? This is iron ball and this is also iron ball, both are iron ball. This is iron ball 2, this is iron ball 1, right? Just iron ball B, A and B, mark it so that we can avoid confusion. Iron ball A and iron ball B. Now this is 50 kg in weight, this is 60 kg in weight. If I say that here is only one ball, here is only one ball and here is number of balls 1 and here is number of balls 2. Now we have to tell that after mixing both the balls, not logically possible, but yes, if we mix these 50 kg balls and 60 kg balls together, what's the average weight comes at the final? That means this is 50 kg balls. You can understand that melting all these balls to form a new one, to form a new ball, and the number of balls may become different, but yes, the total weight, that should be in which direction it would be inclined, that to be understood. Now 50 kg, that is number of ball 1 and 60 kg, that is number of ball 2. That means individually 30 kg, but we will not deal with that. But we will understand that this is but this is not 2, take 3 for a better calculation. This is 1, this is 3. Now the total number of balls here is 1, here is 3. So in which direction it would move? This that means 60 kg in each of these balls. This each ball, this is each ball, right? This is each ball, this is each ball. The total weight, that is 50 kg, total weight, that is 180 kg. Now in which direction they should move? That means 3 kg. Obviously the midpoint should close to this here, right? Whatever the weight would come here, that would not our purpose at right now, but yes, understand it that 50 kg iron ball, this is one unit, that is number is 1, here is 3. So obviously the midpoint, this midpoint should obviously close to this heavier weight, the heavier side, right? That is it. Now if we extend our concept here, in a class some boys are there and some girls are there. So here is boys and here is girls, right? So weight of boys, that is 45 kg each boy, each girl weight is 30 kg. Now what do I say next? That is average weight that should be in medium, that is 35 kg. Can you tell me the ratio of number of boys in the class? I am not saying that what's the exact number, but yes, ratio of number of boys and girls we can easily find out. How? See, this is 35 kg, this is 30 kg. So number of girls should obviously more. Why? Because this weight is difference between boys and average is less than is more than girls and average. So whichever direction this mid value close to, obviously that would be the heavier side. That means girls here is the heavier side and boys is the less in weight, right? So girls here, that is 35 and 30, here is the difference is 5 and here is the difference is 10. Whenever we have to find out the number of boys and girls or the base, whatever the thing we are discussing here, always keep that thing in mind that ratio comes in the base form. That means if we talk here, that is in the weight, this is 50 kg and this is 60 kg, and here is the number. If the number is not given but the mid value here is given, supposedly between 50 and 60, that means if I say here is 55 given, for the better understanding here, just take very simple value 55, that means 5 and 5, both side difference is same. That means the number of balls in 50 kg, if whatever the number of balls here in 50 kg case and the number of balls here in 60 kg case, both are absolutely same. If this is the number is n, this also number is n. I am taking n any positive integer value. Okay, so that is it. Now this 35 kg, whenever this is not exactly in middle but into inclined to a specific direction, then we have to understand that this is the closest side in which the heavier side occurs. That means 30 and 35 kg, here's difference is 5, 35 and 45 kg, here's difference is 10. That means girls is heavier, or the number of girls, weightage of girls is heavier than the boys. So the ratio should be 5:10, which eventually gives 1:2, right? So 1 unit is for boys and 2 unit is for girls. Again, if the total number of boys and girls, total number of students in the class is given supposedly 90, then we can easily check that this is 1:2, 3 unit, that is 90. So 1 unit, that is 30. So number of girls here is 60 and number of boys here is 30. Now you can understand from the cross check motion that this is 30. The 30 is the number of boys, 60 is the number of girls. In which direction the average weight goes to? Obviously this heavier side. That means weightage is heavier. Weightage is more. In that side the average inclines to go, right? So this is 35 kg and this is 30 kg. Close, the difference is less than boys and average. So obviously the weightage of girls is more here. I hope the basic understanding of mixed and alligation you understood. Now moving to solve some questions, and the advanced level of questions we will solve, but not in this session, in the upcoming session. So try to understand these basic questions here, only then you can understand the advanced level question. So moving to the next slide, the first question slide here. The cost of type 1 rice is 15 per kg and type 2 rice, that is 20 per kg, right? Two types of rice there. Now, if both type 1 and type 2 are mixed in the ratio 2:3, then the price of per kg of mixed variety of rice is what? And one more important thing, that I have not taken any options in any of the questions here in this particular session, only for make you understand and be confident about whatever the answer comes, that would be okay, that would be right. So be serious about this fact that there should not be any calculation mistake. Okay, these questions are very easy. Just try to solve the questions at the best possible manner. Okay, so two types, that is type 1, that is rupees 15, and type 2, that is rupees 20 per kg. It's talking about, this is also per kg, this is per kg. Now the ratio of mixing that is given, that is 2:3, right? 2:3. Now 2:3 is mixing. Now what it would be? That is total 2 plus 3, that is total 5 unit, because the ratio of mixing, that is type 1, this is type 1, right, and this is type 2. These two are mixing in the ratio 2:3, and then what's the mixed variety? Mixed variety, what's the per kg rupee comes here. Now this is total 2:3, sums up to 5. Here's the difference is 15 and 20. What's the difference? That is also 5. So 5 divided by 5, that is 1. So 1 unit value is 1. So this 2 unit value, that is 2. Now this 2, whether it goes from 15 addition 17 or 20 minus 2 18, in which way it would move, that would be understood, that should be understood by understanding the ratio here. See, 3 unit of 20, this is heavier, So weightage is heavier, it's 3 unit side. But if weightage is heavier in type 2 side, obviously the reverse value would be subtracted from this higher value, that is rupees 20. Now this 20 minus 2, that is 18 rupees per kg, which is our answer here, right? So rupees 18. Again, you can understand that in which way you should move. Either 15 should be added to 3, that means here 1 unit 1, so 3 should be absolute value in rupees case, that means 3. So 15 addition of 3 18 or addition of 2 17. If you add, suppose if there is 15, now if you add 17, obviously that would be 20. Now this is 15, this is 20. What I have told you, that this is 3, this is 2. Now the ratio should obviously be reversed. Ratio, you have to make it reverse so that you can understand whichever the weightage is more in that side, the ratio or the mean value slightly inclined to that side. Okay, now here the condition is just getting violated. 3:2. What is happening here? 3 unit here, heavier side, that is 15 17. Here it's satisfying because the difference is less. If the difference is less, obviously the weightage of that particular, that is the base 15, would be more. Here it's satisfying. But is this equal to this? No. So this 15, here you can see that weightage is 2. That means the higher value, the difference should be make more. So that is 20 minus 2, that is 18. 18 rupees per kg is the answer here. Moving to next. In what ratio must a grocer mix 2 varieties of tea worth of 60 kg and 65 kg so that by selling this at 68.2 may gain 10%. So 10% gain, that means you can supposedly calculate the cost price from here itself. That means divided by 11. Divided by 11 means not 11 but yes 1.1, right? So 6.6, that means 66, right? Okay. Now this is 66. Okay, so initially that is 60 kg and this is 65 kg. 66, this is 2, right? Not 66, this is 2. Just fix it out. Okay, this is 62, this is 62. Now this is initially one variety, this is the second variety, and this is the mixture. Now this is the mixture. What's the difference here? That is 2. What's the difference here? That is 3. Now is this the difference in which way you have to mix? No, you just simply take the reverse of this. Why? Because you have to calculate the weightage part. This difference, that is 62 and 65, that is more. The difference is more, that means the weightage is less. Simply remember one thing: if the difference is more, the weightage is less. You can remember it like this, and then the reverse of this particular ratio is the answer here. Now the rupees, the 2 varieties, that is 60 kg and 65 kg, and the final mixture that gives 62 rupees as a cost price. Now 2:3, what it comes, but the exact of this thing which gives the final ratio, that is the weightage. Here is the weightage more, so the difference is less. Simply remember like this: difference is less, so weightage is more, that is 3. Difference is more, that means weightage is less. That's it. So 3:2 is the ratio in which way you have to mix the 2 varieties. Next one. How many kilograms of sugar costing rupees 9 per kg must be mixed with 20 kg of the sugar costing 7 rupees per kg? Okay, so first one, weight is not given, but the rupees per kg, that is 9. Second one, 27 kg, yes, and rupees 7 per kg, it's given. Now it's saying there may be a gain of 10% by selling the mixture 9.24. 9.24, that is 11% value. So what is 10% value? That means the final cost price, that is 8.4, right? So this is 8.4. Now what's the difference here? That means 1.4. What's the difference here? That means 0.6. I have told you multiple times that you have to just take the reverse, and if we just simply reduce this value, that is 7:3, right? Now this 3 unit is corresponds to 27. So what is the 7 units? That is 63 kg, right? So I hope you understood this question here, right? Okay, again I am saying that if the difference is less, that means weightage in that particular site is more. That's why we are reversing the ratio part. If the difference is less, then the weightage is more, or vice versa. If the difference is more, weightage is less. Keep that thing in mind. You won't have any confusion. Okay. This is absolutely perfect. Moving to next. A dishonest milkman professes to sell his milk at some cost price, but he mixes it with water and thereby gains 25%. The percentage of water in the mixture is what? Now, this is a very common question. You can surely understand it. See, a dishonest milkman professes to sell his milk at some cost price. That means what? If 1 unit I am selling, 1 unit is the cost price. That's it. But this dishonest milk professes to sell it at some cost price, not making the profit. Here in that case, that you have to understand that this is not making a profit case before the dishonest case is occurring, but he mixes it with water. Whenever he mixes it with water, then the dishonest term comes into play. Now thereby gains 25%. After mixing water, 25% gain is occurring. That means what? 25% means 1 by 4, right? 25% gain is occurring. Now this 4 unit is what? Milk now. And this 1 unit is water. And the question says that this 1 plus 4 total 5 unit earlier, that is the milk. Okay, this 5 unit milk price that would earlier been taken, but right now this not 5 unit is given, but the seller is still taking the money of 5 unit milk, demanding that 5 unit milk he is giving, but this is not actually correct. Here some impurities, that means the water is mixing with it, that's why the gain becomes 25%. Earlier there may be gain, may not be, but that is not our purpose here in this particular question. But he mixes it with water and thereby gains 25%. That means now actually he is giving 4 unit of milk and 1 unit of water, right? This is water and this is milk. Now what's the percentage of water in the mixture? What's the percentage of water in the mixture? That means this is 4 unit, this is 1 unit total, this is 5 unit, and out of this 5 unit, 1 unit of water, that is 1 by 5. So what's the percentage value? That is 20%, which is answer here, right? A jar full of whiskey contains 40% alcohol. Okay. A part of this whiskey is replaced by another containing 19% alcohol. Good. And the percentage of alcohol was found to be 26%. The quantity of whiskey is replaced, right? Keep that thing in mind. This is asking the replaced part. Okay. So we have to be extra careful here. A jar full of whiskey contains 40% alcohol. Okay. Initially 40% alcohol. A part of whiskey is replaced by another containing 19% alcohol. This is 19%. And after mixing these two, it's found to be 26% alcohol present in the mixture. So what's the difference here? That is 7. What's the difference here? That is 14. But will we take the ratio as it is, this 14 ratio 7? No, absolutely not. What I have told you, that if the difference is more, weightage is less. If the difference is less, weightage is more. So you have to take just the reverse of this. That means 7 ratio 14. Now 7 ratio 14 reduced form, that is 1 ratio 2. Now what it is asked, not the ratio, but something different. The quantity of whiskey is replaced. So quantity of whiskey replaced part, that is 19%. 19%, that means this 2 unit is replacing out of what? Out of 3. 1 plus 2, 3. So 2 by 3 part is the replaced part here, right? 2 by 3, which is the answer here. Moving to next. In what ratio water be mixed with milk costing rupees 12 per liter to obtain a mixture worth of 8 rupees per liter? Very easy. We have done similar kind of questions. Rupees 12 per liter initially, but it's now obtained worth of rupees 8 per liter. Obviously some water is mixed, right? Otherwise there is no profit at all. So in what ratio water must be mixed with the milk costing rupees 12 liter to obtain a mixture of 8 rupees per liter? It's saying, the meaning of the question is like that: if 12 liters earlier selling at 12 per liter, that means for the easiness of understanding the concept here, I am saying 12 liters of milk is selling at 12 rupees per liter. That means what? Initially 12 liters of milk, rupees 12 per liter is selling. Now it's saying that the similar quantity is getting sold, and the price of that particular becomes 8 rupees per liter. Obviously there is some impurities. Impurities is what here? That is water, which is freely available. You have to consider that water is freely available until and otherwise it is mentioned. Okay. So this is water is mixed with milk costing rupees 12 per liter to obtain a mixture worth of 8 rupees per liter. Now initially that is 12. Now it's saying that 8 rupees per liter. What's the difference? That is 4. This 4 liters or 4 unit is the water which is being added to the mixture. Now in what ratio water be mixed? That means this is 4 and this is 8. This is the part of water it's getting added and this is the milk, right? So what's the reduced form? That is 1:2, which is the answer here. And in option, it may happen that 1:2 is given, 2:1 is given. Rest of the options I am not talking about, just to for avoiding the confusion here. 1:2, 2:1. In hurry, you may mark 2:1 and you may get it wrong. See what it is asked here. In what ratio water be mixed with milk? Just keep this word very, very seriously. In what ratio water be mixed with milk? First is water, so water is 1 unit. So 1:2 is the answer, not 2:1. Okay, just keep that thing in mind. That will be okay. Moving to next. A container contains 40 liters of milk. From this container, 4 liters of milk was taken out and replaced by water. This process was repeated further 2 times. That means total 3 times this operation is done. How much milk is now contained by the container? Now initially 40 liters of milk. Here is one important concept you have to understand. We have not discussed it earlier. See, here is 40 liters of milk, right? Initially 40 liters of milk. 40 liters of milk. Now finally it is asked how much milk is now contained by the container. And 4 liters of milk is taken out. That is okay. Up to this is okay, and now replaced by water. Replaced by water, that means concentration of milk gets changed. You have to understand this. If initially 40 liters of milk is there and you have to adding something which is not milk but something other quantity, other things you are mixing with the mixture, then obviously the initially milk concentration would go down, right? Think about it. Initially 40 liters of milk is there and then 4 liters of milk, and whatever the percentage of the milk is removed from the mixer and then adding some water or some extra impurity obviously makes the concentration of the initial quantity go down, helps in minimizing or decreasing the concentration of the initial quantity go down, initial whatever the thing available, that is milk here. So concentration of milk is going down after adding the water, or the similar quantity, whatever the quantity of milk is in earlier taken out from the container and then replaced by water, the same quantity obviously helps in reducing the concentration of milk here. Okay, understand this. So a container contains 40 liters of milk. From this 4 liters, we can say that 10 liters of milk is taken out and replaced by water. Now 10 liters is replacing 10 liters, 10% of milk is replaced by water. That means what? Concentration of milk gets changed. So if the concentration of milk gets changed, what's the concentration would be then? That means 9/10, right? 10% is replaced, that means the concentration is just get reversed, that is 9/10, and this 9/10 similar process is repeated further 2 times. So this is 2 times we have to multiple here, right? Total 3 times, and this gives us the final milk quantity, right? Just calculate it here. This is 44, this is 729 multiplied by 4 divided by 100, just leave it out, 729, 29 double 58, 58 double 116, 16 is here, 1 is carry, 4 7 28, 29, 29 by 100, 29.16, right? One more important thing, though this is not important for this particular question, but yes, you have to understand it. If we say that 100 liters of mixture, not here but here, this is not a part of this question, just remember it here, this is a note based, right? 100 liter wine is given, right? 100 liter wine, okay, and mixing is water, replaced by water, replaced by water. Now again 10% replaced by water. First I am saying that 10% replaced by water, then concentration of what concentration of which is getting changed? Obviously the wine. Whatever is getting replaced with, that is not play any important role in changing the concentration, but the remaining part. That means here it's wine. Water is getting added, so concentration of wine would get changed here. That means if 10% is the thing, 10% of the wine is replaced by water, that means the concentration of wine it gets changed, and that is by what part? That is by 9/10 part. And whatever the percentage is given there, in that respect you can simply take the fraction value here. Okay, so this may be 2 times, 3 times it can be, but here it's saying that only replaced by water, and the same process is repeating multiple times. But here I am saying the first is replaced by water, and second case, this is the first case, and second case is replaced by second case. Just calculate it here, just calculate it here. Up to this is what? This is 100, that means 90. This 90 liter wine is present right now, 90 liter wine. This is 90 liter wine. Now this 90 liter wine, now it's saying that replaced by water, but now replaced not by water but some, yes, replaced by water, yes, replaced by water but some different percentage. If we say 25% replaced by water, similarly you can say that 25% replaced by water, that means in fraction value that is 1/4, but 1/4 we will not take, we will take whose concentration would get changed then after adding the water. That means a concentration of wine would get changed, that means 90 multiplied by not 1/4 but 3/4, that is it, right? And similarly I am saying if that is water is given, and in some case it may happen that this is not water given, but at times it saying that concentration of wine gets changed. This may sound something awkward, but yes, this is true. The concentration of water also gets changed. In that sense you have to understand that what the quantity I am adding here. I am adding wine. I am adding wine, that means the concentration of wine would not get changed. The concentration of the remaining quantity, remaining part, that means the water or to some extent some other quantity may be there, that particular thing, concentration would get changed. Whatever the replacing part, that means water, maybe wine, maybe milk, whatever it can be, replacing part would not play any role in changing the concentration. The concentration of that particular would get changed which is already available in the mixture before replacing to some external quantity. Okay, so keep that thing in mind. That is it. And yes, I have told some important thing here. We will solve some advanced level question of this particular. You will definitely understood it better. But by now, whatever I have discussed, that is enough. Please understand it. Okay. So moving to next. A milk vendor has 2 cans of milk. The first contains 25% water, rest is milk. Second contains 50% water and rest is milk. So first container, in first, milk and water. First contains 25% water, that is it. So this is 3, right? 25% water. So 75% milk, that is 3 here. Now in second container, milk and water, that is 1:1. No confusion, 50% is talking about. How much milk should be mixed from each container so as to get 12 liters of milk, such that the ratio of milk and water and milk, see, water and milk it's given. Okay, so do not get any confusion here. 3:5. So we have to deal with milk and water, so this would be 5:3, right? So we will just deal with milk part here, 3 unit, 1 unit, 5 unit, but based on the individual container. That means here it's 3/4, here it's 5/8. After mixing the two, here it's half. So what's the ratio? If we just deal with the milk part, we can deal with the water part as well. Whatever the steps I am following here, just follow it, and you can also deal with the water part as well. Now milk and milk here, that is the denominator part, that is 8 maximum, right? So 3 can be multiplied 6, this is 5, and this is 4, right? Not in ratio form, but yes, okay. Now this difference is 1, and this is also 1, right? So total it's saying that 12 liters of milk are there. Now it's saying that how much milk should be mixed from each of this container, and the ratio is 1:1. Very simple, simply half, so 6 liter, right? 12 divided by 2, which is 6 liter. So this is the answer here. I hope you understood this. Okay, now moving to the next one. A can contains a mixture of two liquids A and B in the ratio 7:5. Okay, so initially the ratio of the two liquids in the mixture, that is A ratio B 7:9. After 9 liters of the mixture is drawn off, after drawing off some mixture, the ratio still be the same, there is no change at all, that means 7:5. Now then it's saying that the can is filled with B again. Now the ratio becomes changed to 7:9. 7:9, one important thing you may note here, that the addition of liquid B. So that's why there is no change in part A. Though this is a ratio form, there may be change, there should have a change, but yes, the ratio is given in such a manner that you can simply understand it. This is 7, this is equal, there is no change at all because A is not adding here, just B is getting added. So this is difference is 4. This 4 corresponds to this 9 unit. 9 units replaced by liquid B. This is 9 liters. So what is 1 unit? That is 2.25 liter, right? Now understand that this is the final ratio 7:9. You may take this ratio, you may consider this ratio 7:9, or you may consider this ratio 7:5. If you take this 7:5, this is already included 9 liter, but this 7:5 is not included 9 liter. If you take this, you may miss something, but you have to follow this one because 9 liters after removing, the ratio still be the same. So if we take this 7:5, that means 12 into 2.25 plus 9, this is the total quantity, the initial total quantity in the mixture, or this 16 into 2.25, both are absolutely same, right? You may calculate any of the two. So this is 8, 36, this is 24, 27, 9, this is also 36 liter, right? Now what it is asked, how many liters of liquid A was contained by the can initially? How many liters of liquid A? So initially 7:5 is the ratio. So we have to find out the 7 part here, out of total 12 part. Out of total 12 part, 12 part is given as 36. We have to find out 7 part. So obviously the proper fraction would come into place. So this is 3. This is 21 liter, which is the answer here, right? 48 liters of glycerin is mixed with 144 liter rose water. Okay. So this is glycerin and this is rose water. D liters of the total mixture, just write it down. This is 48 liter and this is 144 liter. In ratio form, we can write it here. Now D liters of the total mixture is removed and 32 liters of glycerin, 48 liters of rose water are added in the mixture. Add it. 32 liters here and 42 liters rose water here, it's getting added. Then the final mixture contains 30% glycerin. Find the quantity of mixture that is taken out. That means we have to find out D here, right? So 30% glycerin, final mixture contains 30% glycerin, right? If 30% glycerin is here and this is rose water, right? So 30% glycerin means 70% rose water. Now what's the difference between the two? That is 4 unit. Okay, you may calculate it by taking the variable x from 48 and this is 48 and 80. After removing something, that means x can be removed from both of this, and on the basis of the ratio, that is 1:3, x by 4 and 3x by 4, you can do it. But what I am saying here, this is very simple and the shortest approach, that the difference here, that is glycerin and rose water in the final 3:7. So what is the ratio difference? That is 4. What is the ratio difference? Leave it for now, this part, leave it for the time being. Just think about it. Initially 1:3, that means what? Difference is 2. So if this difference is 2, this difference obviously exactly match with this one. This is 4. So make it as 4 difference. What should I do? That is multiplied by 2, 2 and 6. 2 and 6, difference is 4. This is difference is 4. Now this 32 and 48, this difference is what? This difference is 16 liter. Now 16 liter corresponds to 4 unit. Only then the equation satisfy, right? So this 4 unit equals to 16 liter. Now this is 1 unit equals to 4 liter, right? Now what's the total quantity here? That is 192 liter. What is the total quantity here? That is 80 liter, right? Okay. Now Yes, that is fine. Here you can find out the answer, right? Now if we say whatever I was telling earlier, that if we take it, that is 48 minus something, remove something, or adding something, 32 liters is getting added and 144 plus 48 is getting added. Now what's the ratio here? That is 1:3. 1:3 total quantity, that is 4 unit. So x unit and 3x unit remove from this. Now if we remove from here x and if we remove from here 3x, that is okay, right? In ratio form I'm talking about. Now this is 3/7. Just calculate it. This is 80, right? And this is 192. Now this is 7, 560 minus 7x equals to 576 minus 9x. Now this is 2x equals to 16, x equals to 8, right? Now this is x equal to 8. So remove something. So this is 48, right? So do it from here. This is 48 minus 8, this is 40, and 144 minus 24, that is 120, right? So this is 160. Is this okay? 48, 32, right? This is x, this is 3/7, this is glycerin part. This is 144, this is 48, 192, 9x, this is 2, this is 16, x 8. So this is 120, 120, this is 160. Okay, right. So d liters of the mixture is taken out and 32 liter of glycerin and 48 liter of rose water are added in the mixture. Final mixture contains 30% glycerin. Find the quantity of mixture that is taken out. So d liters of the mixture is taken out and 32 liters, these are getting added. So initially 48 liters and 144 liters, and this is getting added. Finally the ratio becomes 3:7. So this is 4 difference, there should be 4 difference, and here is the 4 difference, that is 4 unit 16, 1 unit 4. Now this is total 198, this is total 80, this is getting added. But before getting added, this is getting added, so there is no role of taking the difference of these two, 192 and 80 liter, but we have to take here 48 and 32, this is getting added, and something subtract from this x and 3x part, that is the 4x part we have to find out. So this 4x part is what we have to calculate here. Okay, so this is here, from x part is removing and 3x part is removing. So yes, that is it. So there is no need of calculating this. Okay, see, we have also messed with something that without checking the questions properly we stuck here. But yes, x equals to 4, so this is 1 unit, this is 3 unit, this is 3 unit, and this is 1 unit, so this total 4 unit. So 4 into 8, that is 32 liter, which is removed from the mixture, right? So moving to next one. In a mixture, the ratio of alcohol and water is 6:5. So this is alcohol and this is water, right? 6:5. Now 22 liters of mixture are replaced by water. Now 22 liters of mixture, that means 12 goes from here and 10 goes from here. Now the ratio becomes 9:13, right? But adding this 22 here in this water part, it's saying 22 liters mixture replaced by water, right? So this is 6x minus 12 by 5x plus 12, which is equal to 9/13. Find the quantity of water after replacement. Okay, so this is 78, this is 40, so 33x equals to 12 into 22, which is, if we just take it, this is 3, this is 2, this is 4, so x equal to 8, right? This is x equal to 8. Now x equal to 8, so find the quantity of water after replacement. So we have to find out this part, this 5x plus 12 part, right? So 5 into 8 plus 12, which is equal to 52 later, right? Okay, so this question, yes, just I'm solving it. After that we will come to this. Okay, there is some issues. Answer is not okay. A solution of third sherbet has 15% sugar and a solution has 5% sugar. How many liters of the second solution must be mixed with 20 liters of the first solution to make a solution of 10% sugar? So initially 15% sugar and the solution having 5% sugar. To make the final solution 10% sugar, that should be in between these two. So this ratio here is 5%, here is 5% difference, both cases are same. That means 20 liters of the first solution obviously mixed with 20 liters of the second solution as well. This is 20 liters the first solution. So answer here is 20 liter, right? Okay. Now just understand this question, this 48 liters glycerin once again. This 48 liters glycerin is mixed with 144 liters of rose water. D liters of the total mixture is taken out, okay, something taken out. So we have to deal with the ratio here, that is x is here and 3x is here. So total 4x unit would be taken out from this particular mixture, that is 192 liter initially. Now 32 liters of glycerin and 48 liters of rose water are added in the mixture. If we can't do it like this, but just follow the traditional manner here, 48 minus x plus 32, 144 minus 3x plus 48, that is okay. And this ratio is given as 30% glycerin. 30% glycerin it's containing, that means this is glycerin, okay, this is right. Now this is 80, 80 means 560, this is 192, 576, x 8, and this is 4. This is the total removal part, right? This is x and 3x, 4x, 32 liter. This is okay. Now see if with this way we can solve it. Glycerin and rose water, this is 3 unit, this is 7 unit. Now the difference is 4. Difference is 4. This difference here also, this difference 2:6 we can take. This is this difference 2:6, 4. Now this is the adding part, right? This adding part would also have the same difference, that is 32 and 48. This is 16 unit, this 16 unit, that is 1 unit is 4. Now this 1 unit is 4, this 1 unit, this is 1 and 6, 2 and 6, 12, 6 and 8, this 2 unit and this 6 unit, right? Total is 8, 8 into this 4, again 32 liter, right? Understood? This is 2 here. Earlier what we have taken 1:3, but this is not 1:3 but 2:6. Why I am taking this? Because this is 3:7. We have to match the ratio with the final ratio. Whatever the ratio initially it comes, we have to exactly match with the final ratio, that is 3:7. Difference is 4 here. We have to make this difference is also 4. So the difference is 2, 1:3. We have to multiply this ratio by 2. Then 2:6 comes here. That means the difference is 4, 2:6. So now 1 unit is 4 units. So what's the total unit that is already taken out earlier from the mixture? That is 2 plus 6, 8. 8 into 4, that is 32. Again, it's satisfying, right? So this way, it is also fine. We can solve it, right? Okay, quite a longer discussion for this particular question. This should not be, this should not happen actually. But yes, I hope by now you understood all the questions I have discussed here, and solve some more questions on this level, and we will again solve some more number of questions, some advanced level of questions from mixed and alligation kind of concept wherever it is being applicable, and let's see how efficiently we can solve it, and the mains level questions we will also take into account in the upcoming sessions. Okay, so that is all for now, and good day.